Hey, welcome to the last section of Chapter 13. Finally! Woo! 13.6, the Law of Cosines. So, I had mentioned in 13.5's lesson that we were going to learn 4 different situations for solving triangles. We're going to use the law of cosines to solve for the side angle side case and the side 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 case. And don't worry, we are going to do some practice in class so that you'll be able to determine when you need to use what. But basically, law of sines you want to use when you have an angle and side pair. Law of cosines can be used when you don't have that. We have our typical triangle where angle A is across from side A, angle B across from side B, and angle C across from side C. And when I say across the triangle. Here's 3 different versions of our formula depending on which side you're trying to find or which angle you're given. And then just so you know, you can also rearrange this formula. And when I rearrange this formula, this is what I get for cosine of A. Notice there's a mistake that should be a negative right there, negative 2bc. So please, 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 make sure you change that. Okay, you know what? I take it back. There is no negative there. It was correct. They just are. In my mind, I was thinking that they had forgotten that, but I realize now that they already switched all the negatives. Anyways, all right, so let me show you what we're going to do with this. I'm going to be given some sides and angles. Just like I said before, we always want to solve for the smallest angle first when possible. Otherwise, solve for the second smallest angle. We're going to solve the side lengths to 3 significant digits, angle measures to the nearest degree. Okay, so here's what we need to do then. In our formula, the side that I'm trying to find potentially will go here, b squared, and then I'll scroll back up for a second. I'm going to be using this one then, and notice that angle A and side A go there twice, and notice that angle B is the angle that's across from the side B. So if you're thinking about trying to memorize this formula, I always think of it as the side and the angle that go with each other are the 2 being used here and here, and then the other 2 sides just are repeated in the other part of the formula. All right, here we go. So A is 12, C is 16, and I should have written smaller because I'm going to run out of space, but that's okay. Here we go. Minus 2 times 12 times 16 times cosine of 38 degrees. Notice we are in degrees, so make sure your calculator is in degree mode. Now, the first thing I notice when I look at that is that this whole thing is just numbers. There's no variable in that whole part right there. What that means is I could type in that entire thing into my calculator. The reason I'm making a big deal of this is for the side case, we're not able to type the whole thing into our calculator because I have a variable with the cosine, but I just want to point out now I don't have a variable there, so I could type that all in. When you type that all in, you get approximately 97.4. So then go ahead and square root, and you get 9.87. So B is approximately 9.87. Now here's the deal. You could now use law of cosines to solve for angle A or angle C, but law of sines is much faster than law of cosines. So now that we have, remember how I said you can only use law of sines if you have a side angle pair? Now I have a side angle pair. So now that we have a side angle pair, we're going to use the law of sines. And I got to figure out which angle to solve for first. So when I look at this, side C is larger than side A, so I'm going to find angle A first because it's a smaller angle. So I'm going to use the one I know, which is B, so sine of 38 divided by 9.87, and then I'm going to solve for angle A, so sine of A divided by 12. This is me assuming you remember what we did in 13.5, so I'm going to do this part kind of fast, but again, cross multiply and solve. I end up with approximately 0.7485 equals to sine of A, and again, I did 12 times sine of 38 divided by 9.87. To get rid of my sine, I sine inverse both sides, and I end up with approximately 48.5 degrees for angle A. Once you have found your second angle, finding your third angle is easy because I can just subtract from 180. So 180 subtract 38, subtract 48.5. Oh, I take it back. I guess I was supposed to round to the nearest degree. So there we go, 49. So anyways, this ends up being 93.5, or I guess 94 degrees if I round to the nearest degree. So here are my 3 answers. I am going to go ahead and do B. If you feel like you want to try it on your own, feel free to pause the video and try it, and then you can kind of fast forward while I'm talking. Don't skip example 2 though, because example 2 is something different. So if you decide to skip example 1B, make sure you watch example 2. All right. Anyways, first thing I want to do if I'm not given a picture for example 1B here is draw a quick sketch. And I by any means do not draw these to scale. I'm just kind of sketching in some stuff. So I am given that C is 132 degrees, side A is 8, side B is 9. Okay, because angle C is the angle I know, I have to solve for side C first. So this time I'm going to lead my formula with C squared. So then the things that go here, here, and then here and here will be A and B. And A is 8. And B is 9. And then times cosine of my angle, which is 132 degrees. And again, I can just type that whole thing into my calculator because right now there is no variable. Those are just all numbers. So I end up with 241.4, and then I'm going to square root it. So C is approximately 15.5. Okay, and again, now that I got that, I will use my law of sines because I have a side angle pair I can use, angle C and side C, and then I want to find my smallest angle first, or my second smallest, depending on what's going on here. But I think this is going to be the smallest because I'm going to find the angle A that's across from side A. All right, cross multiply, 8 times sine of 132. Divided by 15.5 is 0.38. And then sine inverse both sides. Angle A ends up being approximately 22.6, so I'll say 23 degrees. And here I go trying to find angle B, and I end up with approximately 25 degrees. If you have any questions, make sure you write them down. Okay, if you're joining me for example 2, I want to just say something quick. We'll talk about this more in class, but have any of you been wondering right now why we haven't had to look for a second triangle? So we can talk more about that in class, but I just want to tell you that if you think about from 0 to 180 degrees, because here x is positive and here x is negative, and x is cosine, between 0 and 180, there's only one positive angle I can find when I'm using cosine to solve. The thing was, when I'm using sine to solve, everything is positive from 0 to 180, so that's why there was 2 possibilities. Again, we can talk more about that when we get to class. Alright, so here's what's going on with the side, side, side case. First I'm going to draw my triangle again. Again, I just make the quickest sketch I can. I don't try to draw it to scale at all. I just draw an ABC, label sides A, B, and C, and that's it. Because I know all 3 sides, I can clearly look at this and think, okay, well, side B is the smallest, angle B is the smallest then. So that means I need to solve for angle B first because it's the smallest angle. And then in my formula, instead of having my variable be right here on this side of the equal sign, here I know what that is. So I'm going to use side B, and you always use the side that's across from the angle you are using. So if I'm using angle B, I use side B here on the left side. And then I'm going to go ahead and fill in the rest. So C and A are both used twice. And there I am. So pause if you need to, make sure you have that written down correctly. Now I need to tell you something that it might be hard for some of you to see this, but quick side note, if I had an equation like this, you guys know I would have to first subtract the 2, right? Then divided by the 4. I just want to show you that my variable now is right here. So these look fancy, but really they're just numbers just like this. So I actually can't just type it all into my calculator. I need to find them. So 8 squared is 64. This plus this is 493. And 2 times 13 times 18 is 468. So again, I can't make it clear enough that this is now like this situation. It's like right here, I have x. So these cannot be combined because I can't combine a number with an x. And in this case, it's not x, it's cosine b, but same thing. It's a variable that we don't know. So I can't combine them. I have to leave them like this. And that means in order to solve my equation, I have to subtract off 493. So I get 64 subtract 493 is negative 429. And then I have to divide both sides by negative 468. And negative 429 divided by negative 468 is 0.916 approximately. And so I just want to point out, same exact steps as what I did on this little side problem. I added or subtracted something first, then I divided something. Added or subtracted that, then I divided. Now, I do have one extra step right now because I know what cosine of b is, but I'm trying to find what regular b is. So I'm going to cosine inverse to get rid of the cosine, and I end up with angle b is approximately 23.6 degrees. So we'll say 24 degrees. Now, because of doing this solving, that is why if you look back up to the top of your page really quick, they have actually created a formula here where you have already have cosine A solved. So what I could have done is I could have said cosine of B equals and then plugged in that formula. But notice that the variables are going to be different because this time I'm using A and C as the two sides, and then B is a side that is across from my angle. So you have to be careful. But you could use that formula instead to find cosine B if you would prefer. See, what this does already is right away it's subtracted off and divided, which we did by hand. I personally prefer to do it this way for whatever reason, so that's what I'm going to show. But you can use the other way if you want. Okay, anyways, just like the other example, now that I have angle B, that gives me a side angle pair. So as soon as I have a side angle pair, I want to use my law of sines. Now, I could use law of cosines, okay? I could. The only reason I don't is because law of sines is so much faster. So again, you could use law of sines, or law of cosines, but I prefer using law of sines. It's so much faster. Okay, I'm going to next find angle C because that is the second smallest angle. And again, I'm assuming you remember how to do this from yesterday. Cross multiply, so 13 times sine of 24 divided by 8, you get 0.651 that time. And then you sine inverse both sides. So angle C is approximately 41 degrees. And last but not least, 180 subtract 24 subtract 41 is approximately 116 degrees. Now when I did this myself, I rounded, so I'm going to have to, just a second, let's check that. Okay, 180 subtract 24 subtract 41, 115. So see, when I did this originally, I used this with the 10th, so that's why mine's a little off, so 115 degrees then. Okay, so just like we did for example 1, we're going to do a second one here. I would say that you should pause and see if you can get the correct setup. See if you can solve for your first angle. I'll give you a hint. You want to solve for angle C first because C is the smallest side. Why don't you go ahead and pause the video and give it a try. So try drawing your triangle, try writing your setup to find C, angle C. All right, here's our setup. Here's what my triangle looks like. I'm trying to find angle C, and when I go through and find some of that stuff, I kind of ran out of space, so maybe I'll write down here a little bit. I got 196 equals. These two together are 890, and then this in front of the cosine is 874. So now I do my normal equation solving. So subtract it off. I get negative 694 equals negative 874 cosine of C. Divide it. Negative 694 divided by negative 874 is approximately 0.794. And then I am going to cosine inverse both sides. $37.4, so we'll round that to 37 degrees then. Awesome! Let us find our second angle. So I'm going to use C as my side angle pair I know, and in your head, think right now, which side, or which angle are we going to try to find next? Which angle are we going to try to find next? Hopefully you said angle A, because I want to find, again, I always want to do the smallest to the largest. It just, if you don't do the smallest to largest, sometimes you get the wrong answers. And there's a complicated way, reason for that, which is much past what we're doing in Algebra 2. So just trust me, go for the smallest angle first. I'm going to do cross multiplying again. 19 times sine of 37. Divided by 14, so I get 0.81 something 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 here, 0.8167 approximately, but I like to just kind of leave it all in my calculator. So if I just kind of leave it all in my calculator, sine inverse of that is approximately 54.8. So I guess I have to round that up to 55 degrees for angle A. And then, last but not least, to find angle B, let's subtract. And I end up with 88 degrees. Cool. Pause if you need to, but when you're done, flip to the back, and I've got one more formula to show you. Okay, this is called Heron's formula, and this is, so I already gave you the Law of Sines area formula. Now I can find the area of any triangle. It doesn't have to be a right triangle, as long as I know all three sides. To use the Law of Sines area formula, I had to know one of the angles. Here, I don't need to know any angle. So here's my formula. And then just so you know, S is just a new variable we're creating, which represents half the perimeter. So you add up all the sides, divide by 2 to get S. All right, first again, make your quick sketch of your picture. So side A is 22, side B is 40, and side C is 50. And then in order to use that formula, I need to know what S is. So S is 1/2 of my three sides added together, 22 plus 40 plus 50. And you end up getting 56 for S. So the area of my triangle is 56, and then I'm going to go through here and each time subtract a side for each one of those parentheses. So first 56 subtract 22, then 56 subtract 40, then 56 subtract 50. Now, I'm noticing that for some of these more complicated formulas, people are typing them in incorrectly because there's lots of different parentheses you're trying to throw in there. I would recommend, before you type this into your calculator, find what each of these parentheses are. And you can kind of do that in your head too, right? 56 subtract 22 is 34. 56 subtract 40 is 16. 56 subtract 50 is 6. And then if you have a calculator like mine, I want all of those multiplied together under the square root, so I do want to actually multiply everything together before close parenthesis. Your calculator might be slightly different as to how you type in a square root, so you might want to actually try this time for this one and make sure you can get the correct answer. And so the correct answer is 427.5 approximately. and it is area, so I'm going to say inches squared. Example 4 is a word problem. Actually, let me tell you, example 3 is the only one I put on here for Heron's formula because it's pretty easy. Example 4 and 5 are actually just 2 word problems using the law of cosines that I taught you previously on the front page. Here we go. Example 4, pitcher's mound on a softball field, 46 feet from home plate. Distance between the bases is 60 feet. How far is the pitcher's mound from first base? Okay, now in order to do anything with law of cosines, I need either side, 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 or side, angle, side. Now in disguise I have side, angle, side, because you can assume that this is a perfect kind of like square that's on its side. So my angle right here is 45 degrees because a square has 90-degree angles, and if I cut it exactly in half, each half would be 45 degrees. So I have enough information in order to solve for this distance right here. And I am remembering that whichever distance I'm solving for, that's the thing that matches with my angle over here. These two are always across from each other. And then what's happening here is 46 and 60 are my other 2 numbers. So 46 squared plus 60 squared minus 2 times 46 times 60 times cosine of 45. And now ask yourself, do I need to do the extra steps for solving it, or is this one of the ones that I can just type right into my calculator? And hopefully you're thinking you can just type it right into your calculator because there's no variable in that part of it. So go ahead and type it all up, and you should end up with 1812 when you type that all up. And then when I square root it, I end up with approximately 42.6 feet. Cool. Example 5, a 15-foot length of pipe. So here's my 15-foot length of pipe. And a 20-foot length of pipe for a sprinkler system are connected in the ground at a 50-degree angle. Okay, so here's my 15-foot pipe, my 20-foot pipe, and that they are connected at 50-degree angle. How far apart are their ends? Ooh, so they're talking about this. So you've just created a triangle. And very conveniently, they've given me everything I need to do my law of cosines again. And that's what the word problems are going to be like for this section. They're going to be pretty straightforward like this. You just have to figure out how your setup goes. And once again, the side and angle that I'm using together go across from each other. So I got x squared and then cosine of 50. And then my other 2 things fill in the rest. So 15 squared plus 20 squared, subtract 2 times 15 times 20, and then times cosine of 50. And this is another easy one like example 4 was, where you can just type the whole thing into your calculator. And you should end up getting approximately 239.327 when you do that. So when you square root the 2 pipes, they are approximately 15.5 feet from each other from end to end. Please write down any questions you have, and feel free to go back and watch 1 or 2 of the examples if you need to, if you weren't quite clear right now on what's going on. Thanks for listening. See you soon.